Hi all, welcome back to my channel, and today we are going to do some math problems. So let's get into it. We're going to do 3.1, which this whole unit is about functions and different, you'll see. So the lesson is actually called Getting Ready for a Pool Party. And okay, so now here's our focus. We're going to graph a function to model a situation and interpret and identify key features of the graph. And then, so the questions that you'll be able to answer today are, how can we create a graph without equations or points being given? And how does a graph tell a story? And how do I describe key features of a graph? So we all know how to graph, right? Desmos has helped us learn how to graph really quickly and efficiently. But the more important thing here is not how to graph, it's being able to describe it and interpret, right? Those are like human characteristics. Your graphing calculator can graph things, right? But you as the kind of like the expert, and some of you are like, Ms. Johnson, I'm not even an expert, but you will be. Your job is to be able to understand the meaning behind that graph, okay? So we have this context and it says, Sylvia has a small pool full of water that needs to be emptied, cleaned, and then refilled for a pool party. And so during the process of getting the pool ready, Sylvia did all of these following activities, each during a different time interval. So here's all the things that she does, and these aren't in order. So she removes water with a single bucket, then she drains, or not then, but, and she drains water with a hose, same rate as filling the pool. And then Sylvia and her two friends removed buckets with her 3 buckets, and then filled the pool with a hose, the same rate as emptying the pool, and then cleaned the empty pool, and then she took a break, and she took a break. So you all, I looked at all of your answers, they were pretty neat. You all like chose them differently. So like, see this person here, Hypatia, does 3, 1, 2, 6, 5, 4. But this one chose 2, 4, 1, 5, 3, 6. This one did 2, 4, no, 1, 4, 2, 6, 5, 3. So all of you chose different orders in which to do it. And so your graphs will then look different. So I'm just going to say, however you did it, it's right. There wasn't a specific order in which I thought you have to do it in this way. There were things that had to come before certain things, right? Like, for example, hopefully you filled the pool after you drained the pool, right? Hopefully you cleaned the empty pool before you filled the pool. And maybe like whatever the case might be. And she could have taken a break wherever she wanted in this whole process. So a bunch of you chose different ways, and your groups did a really good job of kind of like explaining that process. So I'm not really concerned about this page. What I was concerned was this. Now that you have that order, are you able to describe this graph? Are you able to give me a graph? So number 2 says, sketch a possible graph showing the height of the water level in the pool over time. Be sure to include all the activities Sylvia did to prepare for the pool. Remember that the only one activity happened at a time. Think carefully about how each section of your graph will look, labeling where each activity occurs. Does your graph represent a function? Why or why not? Would all graphs created for this situation represent a function? So those are the questions that we want to be able to answer. And I just have to choose someone random in order to do this. So I'm going to choose someone random. Like, I kind of actually don't even want a graph on there. So let's do, actually, yeah. So I'm going to choose this person's. No reason why I'm choosing this person's, just because I don't want the graph to influence your decision. So whoever this is, I don't know who Jagadish Chandra Bose is, but I'm going to choose this person. So they said, first, Sylvia and her 2 friends remove water with her 3 buckets. Okay, then they remove water with a single bucket. Then they cleaned the empty pool, Then they drained water with a hose. Then they filled the pool with a hose, and then they took a break. So I'm assuming a couple of things here, right? So the water that they're draining has to do with when they cleaned the pool, they cleaned it with some water and they had to drain that little bit out. Does that make sense? So there's a little bit of a story here that you guys are all telling me. I'm going to go with this story just because that's the one that they said to do. So I'm going to do it. I'm going to snip this so I don't have to keep like going back and forth. So let me put that here and we hit next. Okay. So we're going to kind of like do this. So it's a sketch a possible graph showing the height of the water level over time. Be sure to include all these activities and remember that only one activity happened at a time. Think carefully how each parts of your graph will look. Okay. So when this person is filling, I'm just going to erase these little random dots here. So when the first thing is happening, it says Sylvia and her two friends remove water with her 3 buckets. Okay. What is that going to look like? What is that going to look like? So first of all, I have to pick somewhere where I want the water to be. So where do you want the water level to be? I'm just going to say it's up here. Sheldon, there's no numbers there. I don't care. So it's up here. Okay. So this is going to be time, and then this is going to be my water level. Okay. So maybe I should put this. This is time, and this is water. I do this. Yeah. Okay. So the very first thing that happens is that Sylvia and her 2 friends are removing buckets of water. So what happens to the water level when, yes, it would look decreasing because we're removing water. Now, can you just think about this for a second? If I took a bucket of water out, does it decrease like this? Or does it straight decrease at like one moment? Okay. Does this make sense? Yeah, it would be a straight decrease. It doesn't slope down. It's not like the water is being drained from the pool. It goes down in like a thing. And this is how I'm envisioning it. Some people are like, no, Ms. Johnson, it's going to go down. So I'm going to draw it like this. So I'm going to pretend, so I'm going to change colors as I change things that are happening. So I'm going to say at one fell swoop, it goes down like a bunch. Okay, kind of looks like, I don't know, I'm gonna like this-ish, like really quickly, it leaves the pool. And then it goes across again, right? You guys all see how it goes, boom. It doesn't go straight down. Now you have to think about why not. Why doesn't it go straight down? That's another thing that you need to think. Why doesn't it go straight down? Why doesn't it do this? Like, why doesn't it go like, is that straight? Yeah, that looks straight. Why doesn't it do that? So like the reason why it doesn't go straight down like this is because technically at one time, the pool is filled at this level, this level, this level, and this level. And that's not the way it works, right? It doesn't work like that. It doesn't, the level of the water is only one thing at a time. Does that make sense? So I'm going to do another one of these. Maybe they do 2 buckets. You do 2 buckets of, how come it's not going here? So they do 2 buckets, I don't know, something like this. And they get more water out. And it goes straight across again, right? So they do 1 set of buckets. They all pull it up at the same time. They do another set of buckets and they pull it up all at the same time. And maybe they do 1 more. I don't know, maybe and they get another set of water out there. Okay, so that's what the 3 buckets part looked like. And so maybe I need to type that. So this is 3 buckets. They told me to like label it, so I'm just going to label it. So that might go like that. Okay. Okay. The next thing that happens, I'm just going to do it in black. The next thing that happens says, so 1, 2, 3. Then they're cleaning the empty pool. Oops. It needs to be more empty, huh? Okay. Sorry. Let's go back to orange. It needs to be empty. They're cleaning an empty pool, so I need to go more. Doop. Okay. I think that's pretty good. Good? Is everybody okay with that? Then they're going to clean the empty pool. What does it look like? What does the water level look like when they're cleaning the empty pool? What does the water level look like as they're cleaning the empty pool? Yeah, it's really low. And it's almost like it goes straight across. But I'm going to make it go a little bit up because you guys all said that this person specifically said, I don't know, maybe like this. I don't know. They're cleaning the empty pool, but for some reason they put more water in because you know when you clean, yeah, it should be a flat line. But according to what they said next, I'm just thinking about what they said next. The next thing that happens is they drain the water with a hose, right? So if they're draining water, they can't drain it from an empty pool. So I just added this here. Okay. Everybody good? Okay, so let's see. 3, 4. Now they're going to drain the water. So I need to type this out. Sorry. This is them cleaning. So then they clean. Okay. And some of you, your answer looks different because you're cleaning an empty pool and it goes straight across like it's a flat line, right? But here, because of whatever this person said next, they said that they were going to drain the water with a hose. And then we're just going to add a little bit of more water in there so that the next thing can happen. Okay. So the next thing is that they drain the water with a hose. So what does that mean when we drain the water with the hose? What does that mean? Like, what does it look like? Now, I love that you guys have to describe this in the chat because you can't show me with your hands, right? Yeah, no more water. But what is the little line that I'm going to draw? What is it going to look like? Yes, no more water. But what is the little line that I'm going to draw? Is it going to go up? Is it going to go flat? Yeah, it's going to go down. Very good. It goes down. Why does it go down? Why does this have to go down? Why does it have to go down? Yeah, because you're draining the water out of the pool. That's what it says. Drain water with the hose. When you're draining something, is the water level going up or is the water level going down? Yeah, it's going down. Okay. The next thing is now we're going to fill the pool with a hose. Now we're going to fill the pool with the hose. And it says same rate as emptying the pool. So what do I need to draw next? Oops, I need to type this out. So this is drain with the hose. I'll put this one down a little bit here so you guys all know. So drain with the hose. Now what happens? It says we have to fill the pool with the hose, but it's going to go as the same rate as emptying a pool. What am I going to do? Good, increases. Okay, so here's me increasing. I need to change colors one more time. So I need to increase it, but it needs to be at the same rate here. So I drew this down like this, and I can't, this is not the same rate. You guys all see? It needs to be the same-ish. So this to me goes down to right one. So I'm going to go up to right one like this, because then that would be the same-ish rate. You guys all see what I'm saying? So it's going to continue on. I just can't draw it in. Let's see. See, it can't. I don't have enough. Space. Do you guys all see what happened there? So here, this is going to be fill with hole. Fill with hose. All right, so this is my function, right? This is it. And I actually just told you the answer. Does this represent a function? Everyone should say what? Yes, very good. Now, look, the reason why this is a function is because if this is time and this is water, remember we talked about like the vertical line test, right? So can you use this edge as my vertical line? As I pass it over, it's only touching 1 point at a time. Do you guys all see that? It's only touching 1 point at a time. Now, regardless of you choosing this one or anybody else's order, as long as you didn't have any like if you had a drop like this, then it's no longer a function, and actually it would be wrong. If you had a line that went like this, straight up and down, it's not a function. And this actually doesn't make sense because according to you, at this time, I don't know, at 2 o'clock, your pool was filled at 10 gallons, 11 gallons, 12 gallons, 13 gallons, 14, 15, 16, 17, 18 gallons, all at the same time. Can that happen? Can your pool be filled with 10 gallons at the same time as 11 gallons, at the same time as 12 gallons, at the same time as 13, 14, 15, all the way up? Can that happen? Want me to say it again? Can your pool be filled with 10 gallons and 11 gallons and 20 gallons at the same time? No, right? So if I asked you, hey, how many gallons are in your pool? Would you say 10, 11, 12, 13, 14, and 15? Could you say that? What if I answered you like that? Hey, Ms. Johnson, how many gallons are in your pool? I don't have a pool, but just pretend. Hey, Ms. Johnson, how many gallons are in your pool right now? I'm like 10, 11, 12, 13, 14, and 20. What would you say to me? What? Exactly. Thanks. Nayeli said that. Oh, I need help. Thanks. Yeah, it doesn't make sense. So this is not a function. So if you had any parts like this, go back and fix your drawing. Okay, so that doesn't work. Very good. So, okay, let's finish up here. So everybody, if you drew it out and it looks way different than what we drew here together, it should still be a function because at any one given point, you only have so many gallons of water in your pool, right? And that's what a function is. A function says for each input, I only have one output. For my question, you can only give me one answer, not like 10, 11, 12, 13, and 20 gallons. That doesn't make sense. Now, if you said, I don't know, somewhere between like 15 and 20 gallons, that's still just one answer. You just didn't give me an exact answer. Do you see the difference? Yeah. Good. All right. So let's go. So is everybody okay with this? Everybody's good? Very good. Very good. Strong work here. All right. So what we're going to do is we're going to skip ready. I'm going to teach. Again, if you're trying to really like hit a home run for this lesson, go here and see if this makes sense to you. So we're going to go over takeaways. Takeaways is kind of like the synopsis of what you should have learned if it made sense to you. So a relation is a function if and only if what? What do I need to type out here? A relation is a function if and only if what? What words will I write? I kind of said it. I'll give you the beginning of it. Each what? Yeah, very good. I need to snip this. Let me snip what you guys wrote. So someone said each input has only one output. Remember, and we talked about this. We talked about this as the birthday function, right? Each person has only one birthday. So I'm going to type this out really quick. Each input has only one output. And so we said you can use the vertical line test for this, of course. Okay. Each input has only one output. Very good. All right, let's move on. A function is considered continuous. You guys remember this word? Continuous. If the graph doesn't have any holes or breaks. Holes or breaks. I should have snipped that picture because I can't go back to it. But do you remember our picture? And it was like, and then it went, and then it went, and then, right? Sorry. Apparently I make noises while I draw. So let's see. Is this considered to be continuous? And you all would say, wait, does it have any breaks? What's a break, Miss Johnson? Like this. Boom, boom. Do you see how there's a huge break here? Yeah. Does this have any holes? Miss Johnson, what's a hole? This is a hole. If I drew you a parabola and I said everybody except for this point right here, and then I erased inside there. Can I erase inside there? Let's try. It was all right. And I made a big old hole here. So it's supposed to be like a different color just so that you know that that's not the function, but there's a hole there. Yeah, like a gap. So I describe continuous as it's a good roller coaster, right? This is a horrible roller coaster track. Look, you're on the roller coaster and you're like, yeah. And then you like, oh my gosh, what happened to you? Right? This one's a horrible one too. Like, yeah. Oh, like you fell off the track. Not good. Here, this one's kind of bumpy, like across, down, woo, right? But there's still no gaps or holes. So this is okay, right? So it's continuous. This one says discontinuous. Look, if it's discontinuous, do you guys all see this break right here? You see this break right here? That's discontinuous. A discontinuous function is a function that is not continuous. When you put your pencil to draw it, you have to lift your pencil up to continue. The function shows a function that is discontinuous, even though the domain is continuous on the interval that's shown. So Ms. Johnson, you can have a domain being continuous, but your graph being discontinuous, So this is an example of that. So let me ask you a question. If you were on this roller coaster, here's a little roller coaster. I'm such a good drawer. I know you guys are thinking, Ms. Johnson, why did you become a teacher when you draw so well? I know. If you were on this roller coaster, is this function a good roller coaster track? Everybody say yes or no in the chat, please. Everyone says, dun, 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 dun. No, it's not a good track. Ms. Johnson, but why? Because see, you're going here and you're like, yeah, we're going to go down soon. And then you like, boom, that's not a good one. No, it's okay. I love when you guys make mistakes. When you make mistakes here, it means you're probably not going to make a mistake during our test. Okay, a couple more. I know we're going a little bit over here. So this is called an interval of increase when you're going up, 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 up on the roller coaster. When you're going down, 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 that's a decrease. Increase, up, 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 up. So if you're not going up or down, if you're not going up or down, it's called constant. When you're just flat, when you're like going back into the place where you get on and get off, that's called constant. Okay, a couple more. Maximum sounds like it is. It's just a place where it's the highest. This is actually called a local maximum because in this window here, it's the highest point. In this window here, this is the lowest point. If it's an absolute maximum, it means it's the highest point of the function, no matter what window you're looking at. So maximum means highest point, minimum means lowest. Okay. This is the range. We've talked about range before. It's all of your values that come out, and your domain is all the values that go in. And last but not least is your x-intercept, which you guys all know. It's where your function crosses your x-axis. Very strong work here. Very, very strong.